Today, we're going to be learning about different air masses and fronts that cause our weather. You'll start today with your foldable. Fold it in half hot dog style and cut up each of the vertical lines until you meet the crease. That should give you 4 nice flaps to work with. Make sure when you start that you have colored pencils. You'll need today a red pencil and a blue pencil, okay, and also a purple pencil. Make sure that you pause often to make your drawings and your notes. Let's get started. My goal for the end of your class today is that you should be able to look at a weather map like this and understand what the different fronts are, which way they're moving, and what the high and low pressure systems mean. So let's get started. Air masses are huge bodies of air that have similar temperature, humidity, and air pressure at any given height. If you have a certain type of weather taking place outside, that's because there's a specific air mass that's influencing your weather. Scientists classify air masses according to temperature and humidity. In North America, we have 4 major air masses that influence our weather: Maritime tropical, Continental tropical, Maritime polar, and Continental polar. You don't have any notes to take on this section, but please just pay attention carefully so you understand where each mass is coming from and what type of weather it brings. Maritime versus continental helps us to decide where the air mass forms and whether it's going to bring warm weather or dry weather. Maritime forms over the ocean, and since the air evaporates over the oceans, this type of weather is going to be very humid. Continental forms over the land. A continental air mass is going to be much drier than a maritime air mass. We also have 2 air masses that decide on the temperature. Tropical air masses are warm air masses from the tropics that bring low pressure. Polar air masses are cold air masses that bring high pressure. If you look at this chart, you can see each of the air masses can be combined by either temperature or their humidity. So if you have maritime tropical, what type of weather would you expect? It's going to bring warm and humid weather. Maritime polar is going to be cool and humid. Polar will bring that cooler weather. Maritime, since it forms over the ocean, will be more humid. Continental tropical is going to be dry because it forms over land, but tropical indicates that it's going to be warm. Continental polar also forms over land, but indicates that it's going to be cool. If you take a look at this map, you can see where each of the following form. So here's something to think about before we continue. Does it take the same amount of time to fly from New York to Los Angeles as it does to fly from Los Angeles to New York? If you think no, you're absolutely correct. It takes about 5 hours and 45 minutes to fly from New York to Los Angeles. It takes about 5 hours and 16 minutes to fly from Los Angeles to New York. This is because you have a tailwind when you're flying east, and when you're flying west, you have a headwind. Very similar to if you're riding your bicycle into the wind, it's more difficult to ride, and if you're riding your bicycle with the wind at your back, it's easier to ride and kind of pushes you along. Well, this wind that we're talking about today is called the jet stream. In the United States, most of our air masses push from the west to the east. And that's why we see the majority of our weather moving this way. For us here in Virginia, if we look out into the Midwestern states, you'll notice that they move across the country. In the continental United States, air masses generally push air. In the continental United States, our air masses usually move in the direction from west to east. They move in three ways. We have prevailing westerlies, which is a major wind belt in the United States that pushes that air from the east to the west. You may have heard of the jet stream. The jet stream is actually part of the prevailing westerlies, which moves from the west to the east. It's along this jet stream that most of our fronts meet. And fronts are just those boundaries where air masses meet. Well, our jet stream affects how air masses are. Jet streams are actually like a river of high-speed wind very high in the troposphere. It has a huge influence on climate. It affects our weather patterns and is about probably 7 miles in altitude. Well, as jet streams blow from the west to the east, you can see that it carries the air masses along their track. We're going to move in and take a look at some of these fronts that it carries. Make sure that you pause often so that way you can get all of our pictures done and do them correctly. What is a front? Well, we define a front as the boundary where air masses meet. Usually, storms and other weather that changes develops along front. As huge masses of air move across land and oceans, they collide with each other, but they don't mix very easily. It's kind of like oil and water. Let's take a look at our first type of front. When you have very rapidly moving cold air and it runs into slow moving warm air, that cold air is more dense and it tends to sink. The warm air is less dense and it tends to rise. When that rapidly moving cold air runs into slow-moving, warm, dense, cold air, it just slides right under the lighter warm air and pushes the warm air upward. This is called a cold front. Cold fronts are usually represented by blue triangles. The triangles are faced on the weather map in the direction that they are moving. So you may notice that the triangles are pointing south if it's moving south, pointing east if it's moving east, or pointing toward the west or north. Cold fronts generally bring clouds and rain, snow, sometimes thunderstorms. Once a cold front moves through, the sky clears very quickly, and this system is over just as fast as it started. The next type of front is when you have a warm air mass taking over a slow-moving cold air mass. The cold air is denser, and the warm air moves up over the cold air. You can see this in our picture. The cold air is represented with a triangle because it takes a long time and is very slow-moving. A warm front is represented by 3 half circles. They're always colored red and faced in the direction that the system is moving. I always kind of remember this as